Okay, so what we're going to be going over is the measurement sheet for our scale drawing. The purpose of the measurement sheet is so that we can take the various measurements of the objects of our rocket, and then using those measurements we are going to create a scale drawing of our rocket. And the scale drawing is going to be important because it is a tool that's going to be used to help us determine if our rocket is going to be stable or not. We're going to be doing a couple of tests to determine the center of mass and the center of pressure. And what you determine from those tests, you're going to find out if your rocket's stable, and if it's not stable, you're going to learn how you can actually make some changes to your rocket in order to make it stable. So for the rocket measurement sheet, we are going to be using metric measurements. And in fact, if we look at our scale drawing sheet, it wants our measurements to be in centimeters. So when I take my measurements of my various objects of my rocket, I'm going to measure them in centimeters. Okay. We've got 4 different objects. We've got the bottle, we've got the nose cone, the fins, and then our completed bottle rocket. And it wants measurements for the length, the width, the diameter, and the circumference. For some of these are kind of repeat values. Like for diameter and circumference, for instance. Well, diameter and circumference, they deal with circles. Okay? So I've got a circle here. The diameter is actually going to measure the distance from one point on the circle across the middle to the opposite side of the circle. So that is our diameter. That is the length, the distance across our circle. We can kind of think of this measurement as the width of our circle. Okay? So when I have an object like the bottle that is a circle, instead of measuring the width of it, I'm going to be measuring the diameter of it because it's circular. So I actually don't have to do the width for my bottle because I'm going to be calculating the diameter of that bottle. Now as far as the circumference of our bottle goes, we want to measure the distance around the circle. So we start at one point and we're measuring the distance around the circle until we reach that point again. Okay? Now our fins most likely are not going to be circles. So when I measure those, I'm going to be just measuring the length and the width, and my fins aren't going to have a diameter or circumference because they are not circles. Okay? So some of these objects will have just length and width. Some of them may have a length, may have a diameter and a circumference, depending on the object that you are measuring. So what I'm going to do is I'm going to jump over to a picture of my rocket, and let me go ahead and draw that real quick. So let's say this is what my rocket looks like. Okay, we've got a nose cone, got a couple fins. Okay. What I'm going to do is I'm going to take my ruler, and I want to make sure that the ruler I have has the metric measurements. Okay. And when I'm looking at this ruler, it says mm here, which is millimeters. The millimeters are actually the very tiny marks. So when I'm measuring in centimeters, I'm looking at the large numbers, the 1, the 2, the 3, the 4, and so forth are my centimeters. So I'm going to be using large values. And of course, if it ends up like halfway in between, I want to include the decimal point, like 4.5, if it ends up halfway between 4 and 5. Now, in order to help you measure your rocket, and let me kick over to the webcam. So let's say I have my rocket here. Okay. In order to measure the circumference of the rocket, it's going to be useful to get some string and to tie that around the rocket and find out what the distance is from one point to the other, and then you can measure the string. Okay. For measuring the diameter of the rocket, though, since that's the distance from one point across the center of the circle to the other point, you're kind of going to have to put the ruler in front of it or behind it and kind of eyeball where the edge of the rocket is on both sides in order to make your measurements. Okay. Now, the purpose of making these drawings these measurements is because we're going to convert this into a scale drawing. Your scale drawing should end up looking exactly like the rocket that you measured. So for instance, the fins here, we've actually got a couple different ways that we could measure the length of these fins, because we've got right here a point, and then we've got a point here that's attached to the rocket, okay? And we could measure that length, and that's the length that is attached to the rocket, okay? But then we've also got some space here that goes past the end of the rocket that is not attached to it. So we could actually measure the length from the bottom point here all the way up into this top point, but then it would also be useful to know what the measurement was for the part that was attached to the rocket as well. So you may actually need to take a couple different measurements for the length when you have a fin that is an interesting shape. Okay? Now, once you get your measurements, let me flip back to my chart here. So let's assume that I completed all of my measurements and I found out that, say, let's just put some values in here. How about the bottle diameter is 20 centimeters. The length was, how about 15 centimeters? And I'm just throwing in random numbers here, so it's going to look kind of funny when I draw it. My nose cone, how about 10 centimeters? And now I'm going to use these values, and you want to make sure you get the rest of them as well, to draw my scale drawing. So I'm going to go over to my scale drawing sheet, and I can see that the scale for my drawing is 1 square is equal to 2 centimeters. So if the diameter of my bottle is 20 centimeters, if 1 square is equal to 2 centimeters, then 10 squares is going to be equal to 20 centimeters. So I'm converting the number of centimeters into how many squares it would represent. In this case, I would be dividing by 2 to find out how many squares it's going to be. So my bottle diameter is actually going to end up being 10 squares. So I'm going to start at one point and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be my diameter. Now the length of my bottle ended up being 15 centimeters. So half of 15, to find out how many squares, is going to be 7.5 squares. Would be the same as 15 centimeters in this scale. So I'm going to go 7.5 squares. 1, 2, 3, 4, 5, 6, 7, and then a half. Okay, and that was the length of my bottle. All right, and then I can draw the line across. So that would be my bottle, and we can kind of tell that my measurements were not accurate, and these numbers I threw in doesn't really represent the bottle. Now the nose cone, for instance, that was 10 centimeters, so that means that that would be the same as 5 squares. So my nose cone would be 1, 2, 3, 4, 5, and my nose cone was symmetrical, so it went 1, 2, 3, 4, 5 over was the tip, because 10 across was the diameter. And then I will sketch out my nose cone, okay, and then I will continue sketching my rocket with fins based on my measurements according to the scale. Now this scale drawing, I can tell right away I screwed something up, because my rocket body is way too wide compared to the length. So I would want to go back and check my measurements, because that means either I messed up the measurement for the diameter and that value is way too large, or maybe I messed up my value for the length, and this value should be a lot larger than it is, because my finished scale drawing should look exactly like your rocket, just a smaller version of it. Okay, so that is the measurement sheet and how to use your measurements in order to make your scale drawing.